Let's look at Great Expectations and do a demo of the product. Now, if you're not familiar with Great Expectations, in the data engineering circle, Great Expectations help with an open standard for data quality, as it says on their website. So, for data engineering teams, there is nothing more disappointing than putting data out of bad quality. If your data is not correct, people don't trust the reports. People don't trust your machine learning models. People don't trust your pipelines, and it's just a complete waste of time putting data out that people do not trust. So it's very important for data teams to ensure data quality is built into their pipelines, so that when the reports goes out, when the applications are built, or when the machine learning model has been built based on your data, people can actually trust that. And Great Expectations provides the capabilities to do that. So you can check out on the website if you're not familiar with Great Expectations. um, it's definitely something that data engineering teams should be paying attention to. On the engineering side of software engineering, there's already been that culture of testing code before it's pushed to production, with unit testing and a whole suite of testing that can be done before code ever makes it into production. Whether you're building a website, a web app, or a mobile phone app, there's already been methodologies around that for testing, and the data side of things is catching up and putting in those practices. So if you're doing CI/CD, having test suites in this case, which is called Grid Expectations. What do you expect of your data becomes really key, and you can see some of the examples here for Grid Expectations, and that's what it is. So I'll recommend you check out the site to get familiar with it. And in here as well, they have a library of expectations, expecting null values, expecting data to be within certain ranges, expecting data types to be of certain percentages. If you want distinct values on a column and you get values that are not distinct, can you flag that out? So there's just a whole suite of expectations you can deploy to your data set as far as Great Expectation is concerned. Now, for the average person jumping into Great Expectation, it could be very daunting. And what I'm going to do here is go through a demo um, put together by dataroots.io. It was such a phenomenal demo that um, I just couldn't help but surface this up. So if you want to follow, I'm going to leave a link to this GitHub repo. It's just a phenomenal repo, like a gold standard when it comes to people putting out documentation. This is what stood out to me looking at it, that the team at dataroots.io put out. This is what we're going to go through, and you can check out Dataroots. I wasn't very familiar with the company. Just came across it as I was researching about Great Expectation, and you can check out your website here. But what we're gonna focus on, I'm gonna leave both links to the repo and to the demo we're gonna do here in the comment section below, or in the description below as well. So what we're gonna do is just go through the demo. If you have access to the GitHub repo, I recommend go ahead and go through the repo. Is going to give a hands-on experience working with Great Expectations in your data pipelines. So whether you have data coming from Snowflake or just files, you want to make sure that the quality of that data is in meets a certain standard, meets a certain expectation, so that your results that goes to consumers downstream, they can trust that data. Great Expectations is what you're going to want to use. So coming here to this repo, you can clone the repo. But what we're going to do is the beauty, and why I love this was there is a notebook included as part of the repo. Now, if you went to the Great Expectation website and did your own installation of Great Expectations and the actual setup of it, so let's go to documentation. So if you went in there, you did the documentation and do Great Expectations in it, a lot of this that you're going to see would be set up locally on your machine. And when you run your expectations, it actually generates a notebook that you can follow. But that's not the direction I'm using for the demo. But in case you wanted to go that direction, just go to the guide here, follow this. It seems to be very, very straightforward. But just to understand the constructs within Great Expectations, I think we're gonna get a lot of that by looking at this tutorial provided by the folks from dataroots.io. So let's dive right in. As you can imagine, the role for Great Expectations is data coming in from some data source, and you're going to be doing some data engineering and building data pipelines around that data. But also you want that data to be you expect that data to be of a certain quality. Does Should the data have no values? Should it have missing values? Should the values be of a certain percentage? If you're getting, say, sales data coming from a point of sale system, and the average transaction for your sales data should be under $100, and all of a sudden a transaction comes in there for $200,000, is that correct? That might be bad data, and you want to flag that and send it out of your data set or have somebody look at it. So there are many use cases where you want to make sure you're doing expectations around your data, and that's where Great Expectation comes into play. It plugs in into your airflows of the world. Great Expectation is not a data pipeline, it's not an orchestration tool. That's where you have airflow and dbts being useful, and Great Expectations is plugs in into all of that to do what it does, which is validation and quality around that. Now, a little bit of background is built on Python. So a lot of what you see here, it would be Python based for these expectations. So if you're comfortable with Python, I think you're gonna love this. Now, to get started with Great Expectations, and this demo here would show exactly the main primitives that you need to know for Great Expectations to get up and running with this. So here is just getting that Git repo uh, and getting everything set up. So just imagine if I went back here, we're just basically cloning that repo, which you can do and run that in a Docker container. But here we're running this in a Google Colab notebook, running here in the cloud. So let's just go ahead and run that. It's not authored by Google. It's gonna pull from GitHub. I think that's fine. I'm okay with that. Now, the next thing that you want to do is just go ahead, import Great Expectations as GE, right? So it's just a module that is needed in Python, and that gets imported. So just run that, very simple. And the way Great Expectation works, and why I love this notebook too, is there's good documentation around it. So once we have that imported that package, now we can just set a context. So like the way you set a context with any configuration you import, we're setting a context there. And the next piece here is creating, and I'm just running that as we go through, is creating a suite. And this is, I've seen different names for this. Think about this as a test suite where you define the test suite, and we're calling this check avocado data. So we're going to be working with some data sets for avocado, and to check for quality for that data. So we're creating a test suite or an expectation suite in which we're gonna put in a bunch of different test cases. That way, if we have data coming in, we can just run that suite, and the suite is gonna run through a battery of tests that are included as part of that suite. So that's the best way to describe this. So we're defining a suite here called check avocado, and that's basically what the suite is. Once we have that, this is just loading a data set. If you're running through the Colab notebook, you don't have to worry about the files. If you're running locally, you can point to make sure the data set is within the path accessible to your script. So this is loading the avocado data set CSV, and we can do a head of that to see what is in that avocado. So it's just a plain relational file with date, average price for. So you can imagine a store selling avocado, total volume, and bag, small bag, large bag, and some other information around it, the year, and also the region where the avocado is sold. So this is what the data looks like, but there's opportunity here for us to get bad data. We might get dates that are not formatted correctly coming into our data set and breaking our pipelines. We might get prices that are out of range and not correct. And we want to ensure that before we're loading data, or if we're doing data engineering, we're flagging out prices that are out of range and fixing those. We might get sales happening in phantom regions, in regions that are not in the US. If you get a sale coming from Patagonia in South America, that might not be where you sell avocado. And so somebody wants to flag that. Or if there is a sale happening in some place in the world where avocado is not sold, you want to flag that. So our data looks like this, but there's opportunity for tons and tons of errors just intuitively looking at this. And maybe documentation was provided for that data set, but still documenting what the data set is doesn't guarantee that when the data comes through, it would be correct. We still need to run those quality checks, those validations, all those expectations of the data. And one of the beauties about great expectations too is once you go through and you set up those expectations, it's almost like documenting your data. And so if somebody else is coming to your data or working with your code and they read through the expectations, they have a good idea. This is almost documentation as code. They have a good idea of what is in your data. So if you're wondering why go through the hassle of doing all these great expectations, if nothing else, you've documented your data if you go through that exercise as part of it. All right. So this is the data set in the CSV file coming in. And then here, with great expectations, since the badge has been set, so we've set up, we've gotten the file and we're setting a context as batch. And once we have a batch, so batch is is the data that's coming through that we can then execute expectations against. So now we have a batch here. It's executing. We're gonna execute an expectation against that batch. So here the expectation will be, and this is what the syntax really looks like at the end of the day, is bash dot what expectation are we trying to execute on that data, on that batch, and what the column. So here we're saying expect column to exist. So in our data set, there should be this. So think about this as a test. They just call it here expectation. So in our data set, there should be a column called date. If we get a file coming in and there's a column that's not called date, we can imagine that this expectation would break. And if you do batch dot um, this IDE doesn't give me IntelliSense to predict, or it actually does. It took a while, right? So here, if you just do batch.expect, you can see a whole library of expectations you can use for your batch for your data, and these are pre-built. So think about this as pre-built functions in Python that you can deploy on your data to validate expectations, or pre-built methods that you can deploy on your data. So here you can check for distinct values to be inset. You can check for proportions of data, parameterizations, check for unique values, check for entire columns, and just a lot of things that you can do depending on what the validation you need to be performed on your data. Now, if specific expectations don't exist, I believe there are ways for you to go ahead and create your own expectations, because an organization might want to validate customer number in a specific format, or validate zip code, or say social security. We know this the format of social security for those in the United States, but maybe your customers have some internal account number assigned to them, whose format is different, and you want to validate that with your own custom expectation. You can do that, and that becomes part of the library. So here, let's just do batch expect columns column date to exist in that data. We know it does exist, and so by running that, we get some results here. The key thing here is to look at success being true, and that being true is just telling us that column exists, right? You can imagine if it wasn't true, we'll get a false result here. And now, as we're going through this, it's almost like lazy execution. We've executed this badge, and now the badge has been added to this particular test, has been added to a suite, which we did here at the very beginning. And this will come in handy, this check avocado suite. Because once you have your suite, you add a bunch of tests or a bunch of expectations to it. Now you can just execute that suite, and all those expectations would should run and give you a result. So that would become apparent towards the end of this, and I think we'll see how it all comes together. All right, so we have batch that expect column. to exist. The next thing here is we can look at columns. We're just going to see a couple of different types of expectations. We can also expect column values to not be null, a very typical problem you run to when working with data sets. Uh, you get columns with null values, and how do you treat null values? Is that correct data? Is it missing data? For example, you have a sale, but the sale has no transaction date or no sale date. That's a problem because you cannot have a sale without a sale date. So in those cases, you don't want null values. But there might be cases where you want null values. So for example, I don't know. I can't even think of one off my feet here. But there might be really cases where you don't want no value. For somebody maybe doesn't want to put their preference for color, or somebody doesn't have a title. So like Doctor Fru or Mister Fru, somebody decides that they don't want to have a title in their name. So in that case, it's no is allowed. But if you're working with a customer record and they want birthday, you want birth date for your customers, but some customer doesn't have birth date, that might be a problem because you assume everybody has a birth date. So null should not be allowed. Just giving some examples where this could be useful to check for quality in your data as this comes through. So let's run this for check for nulls, and success is true. And this result does have a ton of details. This results coming out here, it gives success. It talks about how many elements were checked for that success to be true, unexpected record count. So if this result wasn't true, we should see the unexpected counts showing up in here, and the percentage, which is just the percentage of bad records, will also show up here. And then it also would give a list of those problem records. So the ones that failed that expectation would also show up here in the list, in this array. And you can that becomes useful for visualization or for building reports on top of that. So just one other expectation to check for null values as well. And there are different types of expectations. You can also check for values to be of a specific type, something that is very, very common to validate. If you have a column that should be of date type, are people actually sending you date type in that column? If you have a column that should be of string, are you actually getting strings in that column? And this check or this expectation would do that. So again, you're executing on the batch. So batch dot expect column values to be of type. So what is the column? The column is region, and the type is string. So that's what's expected. So very straightforward syntax. So let's go back here. We have region. We should expect region to be of string. Now, if somehow we saw numbers in here, that could be a problem. So if somebody decided to put a zip code instead of a region, then that becomes a problem. And this expectation should catch that. We have expectations around dates too as well. Are dates of the correct format? People tend to send dates, especially if you have a global company doing business around the world. In some places, dates are formatted in year, month, date. In some cases, it's day, month, year. But if you're doing UTC format, not everybody still adheres to that. So just making sure that you check, trust but verify, and have those expectations in place would ensure that your downstream pipelines are always guaranteed to have data that has passed expectations, that have met the expectations you've set for that data. So this is another one here as well. It does have the results that are checked. So this is just checking against the entire data set. And are there any missing values or unexpected count and unexpected percentage, and the list of partial unexpected list. So this is where the errors would show if there were errors. Now the difference between missing counts is if your data has no values or it's just missing. So not no, it's just missing data. There's no data came through for that place, which is the complete null. That shows up here. Now, but it's different for missing count versus unexpected because unexpected is based on the elements that actually have data. But if data doesn't show up, then you're not counting that against unexpected. Hopefully that makes sense. So let's say you have 100 records. 100 rows coming in, but 50 of them is missing. So value, there's no value there. And then the remaining 50, there is value, but those values have wrong data types. So 25 of them have wrong data types. So in your unexpected count, you see 25. In your missing count, there'll be 50. And the percentage of missing of unexpected percent would be um, 50%, because it would be 25 of the 50 that was actually there, not 25 of 100. I think hopefully that makes sense there. So just to pay attention of the difference between the missing count and the unexpected count. And then you can also do expectations of the format of checking for ranges. Very common, depending on the industry. You might have price coming in. You want price to be of a certain percentage or a certain value, not depending on your skills and the products you sell, between 0.5 and 3% and $3 in this case, or whatever currency you use. Now, if prices are up outside of that range, you want to flag that. So, like we've run this against that data set, prices should be 0.5 to 3. But here, we're getting all the good details we talked about. But then you see a list of prices that are not within that range. So that could be a problem. And somebody will want to go look at this to say, why are we getting prices of 317 if you have no item in your store or in your business for 317, and somebody sending you data for this price? That could be a cause for concern to go look at. So definitely something to pay attention to. And then but if there are exceptions where um price, you still want that mean and max value for prices, but you want to give some flexibility to go above that with a certain percentage, you can do that. So let's say mostly, and this is where the mostly comes into play in this function, which is another parameter. So if most of your price, so 99% of it, is within this range, but you have a 0.01 percent that is not within this range, you still want to account for that without necessarily counting that as errors. So this gives that flexibility to handle those edge cases. Now, if those edge cases gets to be more than what you've allowed here, then you flag that. So that gives that flexibility for that. Let's just run that, and this is what the result shows with that flexibility. Another scenario for checking for expectations tool would be distinct values. So let's going back to our region, or the type of data. You can check this against region, or you can check for specific data types. So there is a column of type. So in our business, in the case of this demo, if the type of avocado you can sell is just conventional or organic, you want to ensure that whatever the data you're coming in for that column has just conventional or organic, nothing more, nothing less, right? So just those two should show up in your column. Now, if somebody sends you a data set that in the column of type has plastic, then that'll be a problem, because there's no avocado that's of type plastic. And that would be something that you want to flag out in your as part of your test result that has failed. So we've run this. We can see that again, all the data shows up in there. The results, what was observed was everything fell within this range, which is what's expected, and these are the number of records that that the expectations was run against. So pretty good. Next piece here is there's a lot more things you can do: callback, lead-by divergence. I'm not extremely familiar with this callback, lead-by divergence, but again, you can do tests for distribution and lots of things in there. So I'll just recommend you, if you're familiar with that and working with this notebook, to see exactly what that does. Now, um, these are the expectations that could be, or just a subset of the expectations that you can do against your data. And if an expectation doesn't exist, so going back here to some of the expectations, there is over 90 total expectations or functions that are available to use here on the grid expectations. So reuse them, and there's documentation on how to use. And if something doesn't exist, you can definitely create your own. But once we've run those expectations, you might say, as a user, how do I consume that? How do I have to manually run a notebook like this every single morning or every single time we do our ETL? That just isn't practical. It just would not be practical for the average person to do something like that. So that's where the next piece of this notebook would show us. Let me get to the right spot. Will show us how those expectation suites come into play. So if you remember, we had the batch expectation suite. Here we can run to say, hey, show me for this batch, get the expectation suite for it. And because we've run the different expectations, it tells us all the different expectations that are part of the suite. So in here, there is and if you don't like the term expectations, use test, right? So all the different tests that are part of this suite. So here there is a expectation for column to exist, which we saw for date. Column to not be null, we saw for region. The data type to be string, we saw that for region. Date to be of a specific format, average price, you name it. So all of those different expectations are part of the suite. And what was the suite name? The suite name was check avocado. So now you have a suite. If you have a new data coming in or a new batch coming in, guess what? You run this suite, you invoke that suite, and it runs through the battery of tests, and you have your result. Okay. So this is this suite. So you can imagine a suite just has a bunch of expectations embedded within the suite, and you can just invoke the suite. All right. So here is you just running this to say, hey, save all the expectations in that suite. Now, what is happening is if you actually installed Great Expectations locally, there will be a folder for expectations, and this suite will show up in that folder. It's just unfortunate we're not seeing that here because we're running it from the UI, but just something to be aware of if you have to set this locally, that you might see something like that. And I believe it actually shows the tree here, which is great that we see the tree. So once you install Great Expectations, if you're running this locally, you have a folder for Great Expectations. There'll be a folder for checkpoints. There'll be a folder for expectations. So because we've saved these expectations, check avocado.data. When we did that save, it saved that into this expectations folder. So now we have a suite that we can rerun over and over. And there's also a YAML file where you can specify other configurations as part of that setup if you're going to be doing this locally. And then it also would generate notebooks that you can use and run. So very similar to the notebook we're going through here, those will be generated, and some other configurations that you can do and plugins and all of that. So really great. And if we cut uh, that JSON file that was saved, you can see all these expectations, which we call check avocado, is part of that. You can send this to your development team, or to the production team, or to your test team, or your DevOps team, and they can just rerun this whenever there is a change. It runs through this battery of expectations. If there is a failure, then you take the necessary actions to remediate that failure. All right. So now once we have the the expectations set up, it's time to do the actual validation. So think about invoking that expectation. So let's just go ahead and run that, and you're running the expectation against a batch. So we're running that against the specific batch, and we can go ahead and see the result once that expectation has been run. Then for each of these expectations, you can see the results that are coming from. So This one was, I think, checking for conventional organic. We had some null values check. We had to check if something's was strings. So all of this has generated this JSON document for us as part of running this validator expectation. So and I would recommend you go ahead and read the idea of data validators, but that's basically what invokes and run the expectations for us. So now we have this. This result is actually saved in should be saved. Let's just go back up here. It should be saved in the checkpoints. So checkpoints would save. So there'll be a folder called checkpoints if you're running this locally. Though the result of your expectations will be saved in checkpoints. I'm not sure why it's called checkpoints, but that's where you're gonna want to look for this JSON file. I think I misspoke. It's actually stored in uncommitted. I misspoke there. It's stored in. This doesn't happen to have uncommitted, but something to check out on your own installation where exactly that result is stored. It should be stored in I guess it's in uncommitted, and let's just check out the tree. So great expectations, uncommitted validations, and that's where you see those results for each run stored. So and there are ways to change this instead of just storing in your local directories or local files to store to like a cloud object store or to your favorite database, which is if I was doing this in production, of course, I'm not gonna be. I wouldn't be having developers store things locally. You want to push that to a central database and do your reporting or your visualization on top. And this is where let's see the options for Metastore for the different configurations. So you can use different Metastores to store the results. And these are some of the examples for Metastores you can use. So blob storage, Postgres, and file system, and metric store, and a few others. So something to check out if you're deploying this in a production perspective. Now, next piece here is Datadogs. And Datadogs is really what makes part of what makes this very, very beautiful um, for visualizing the results of uh, the results of the different expectations you've run. So here we're just running context.open datadogs, which you can see that if you're running in uh, locally, you can see that. But because I'm running this in just a shared Google Colabs here, let's actually click on this and see if we can open the Datadog. This is the example this team ran. And think about the Datadog as just being the UI on top of those results that we ran. Because again, the average person, if you're gonna be working with your manager or sending this to the team lead, they might not be looking at files and JSON. People don't typically look at JSON to consume data. So having this visualization on top makes that really great. And if you have an installation, of course, you have this. So this one is just a sample of it. So here you see the run. The suite that was run against is check avocado. You can click on that suite, and the suite gives you almost a documentation of what that data is expected. So this is the expectation that we're looking at: the date, the average price, all the expectations that we define shows up in here. So, for example, date is a required field. The values must match this, and this is why I think I mentioned at the beginning or somewhere in the presentation that this is almost a documentation. So think about saving this HTML, and this becomes a documentation of your data, and documentation as code because it's generated as JSON. And if somebody new joins your team, they know exactly what this data is about, and you can put in more stuff here to give them an idea of what the data is about. So that's the documentation. But let's go back before we leave this into the actual run of that expectation, so we can see that the expectation did run. Um, this is a previous run, but just to give you an idea on this suite that ran, the data set that was used, the status, and the different expectations. So here, this was checking for the average price, and the unexpected values. You can see that a lot of records here and that did not meet the expectations are showing up, and somebody can go in to fix this, or to remediate this appropriately. Date, it seems like everything passed there, and just keep going down. It tells you the expectation and the results of that expectations and the batch, and just a lot of good information here to make sure that data quality meets your needs. And you can look at just field expectations, or you can look at every expectations. You can go in and take on a specific column that you want to drill down into and take a look at it. Now, something to call out is great expectations doesn't actually store your data. So it's what it just stores here is the metadata. Your actual data stays on your platform. Snowflake, if you're running this against using dbt as in dbt as an example, it stays in Snowflake, and what just shows up here in this UI is just the metadata. So should be lightweight. Next piece is data context that you can set up for the great expectations. So, and data context could be, so think about it as a source of your data, um, where it could be Snowflake, it could be all the different data sources that you're trying to connect against, or some SQL database, or whatever it is. Data context allows you to set up or set that up. And I'll recommend you just read through to see the options for setting that locally, and how to configure that in the great expectations the YAML file, on setting up different data contexts that you might want to do expectations against. And I think I talked about checkpoints already too as well, where checkpoints is a little bit more involved, where if you have a combination of a badge and a specific expectation that is executed, you can almost think about that as a checkpoint, because your expectations can change or your badge can change, and those two combined at any point in time gives you kind of a checkpoint, which is a little bit different than if you think about checkpoint from traditional programming. So just another concept within this that is something you might also come across. So here, a checkpoint is a combination of a badge and a validation operator. And badge is basically, just think about it as your data, and the operator, or the expectation that was run against it. All right, and that becomes your checkpoint. Now, one other thing to call out here, and I'm happy that they included this in as part of this tutorial or this demo, is the idea of profiling, because we started this by creating expectations on the data set that we have, based on knowledge that has been provided, or knowledge that you have. So, for example, dates should be this format, or region should be this format, or time should be this format, or whatever column should be whatever expectations you have. But you don't always know that. It's not always guaranteed that the data you have the documentation, or you know what the data should be. It might just be a new table you're looking at, and you're just trying to just understand what it's all about. So this idea of being able to profile that data to give you some of those insights, that could inform creating the expectations for future data, I think is a very powerful capability. So here is just doing great expectations, doing a profile against a data source. So you point into a data source, great expectations goes there, it profiles it, and it gives you some information on the columns and what it sees in there. So it's just gonna give really good information, and I think I might not be able to see this because it's running locally here, but there is a result from a previous run, just to give an idea of what that would look like. So this is kind of what the profiling would give. So you can see date. It would talk about based on the profile, it's of type string. Uh, Distinct values is that percentage. Missing values, there's none. Example values as this. So if I was gonna write an expectations based on this, I would know that okay, let's expect the format to be year, month, date, and that could be an expectation. All right, let's expect that there shouldn't be missing values. Let's expect you name it based on the insights you draw from this. So you can do that profiling on the different columns. Let's go to the region, right? So these are example values for the profiling tells us it's of type string. Uh, there are no missing values. And so this could be a good starting point to create your own expectation, even if there wasn't a documentation about the expectations as before. And then some of this you can run to using the CLI, and if you're looking for the commands, so this would just be great expectations help to give almost like a help doc. Some of the commands that are available to run if you're running this locally. So there you have it. And then at the end here, if you need more info around this, this tutorial was put together by the folks at dataroots.io. A really, really thorough put together um, notebook and tutorial with lots of explanation on what's going on. So I'll leave this again in the comment section below. If you're thinking about great expectations, or you're using great expectation, I just want to elevate your skills, or understand it a little bit more, or have folks level up on great expectations, I'll recommend they take a look at this. It's a great resource available on GitHub as well, and that was put together just to call it out one more time by the folks at dataroots.io. So check it out. All of this will be in the description below. And as always, thank you for watching, sticking to the end. Um, Hopefully this was helpful. If you have any questions, don't hesitate to help. Let me know in the comment section below. I'll see what I can do. And if there are topics that you want me to make a video about, to discuss about, to demo, to share, or to bring somebody on the channel and interview them about, don't hesitate to let me know in the comment section below, and I will definitely see what I can do. Again, thank you all for watching. This has been Fru. You have been awesome. I'll see you in the next presentation.